contributor, a very advanced CAD/CAD coder. He's originally a mechatronics engineer, has a background in bio-inspired robotics and controls engineering, all of that good stuff that's very helpful for token engineering. And he's gonna give an introduction on, that's a bit more beginners focused. And I want to, just before we start, put one thing out there. We want to show our faces in this community, and also not only between each other, but also to the outside world. So I'd love if everybody could just like switch on his or her camera, and then we can take a group picture as well. Just want to throw this out there. Go ahead, Ben.
Thanks, Jonathan. Can you see my presentation?
Yeah.
Great. Okay, I'm going to be giving a technical introduction to bonding curves specifically for beginners. And this is to give you a basic overview of the landscape of bonding curves. And a few of the goals that I'd like to achieve with this is that by the end of this, you'll be able to speak to your friends about bonding curves. You'll understand a bit of the lingo that's involved. You'll get an idea of how bonding curves have evolved and been extended upon, and also gain confidence generally in token engineering and being able to explore the space a little bit deeper. Bonding curves are a very core component of a lot of token engineering systems. And some of the basic properties that you've learned a bit about already from Simon are that you've got a function, which is at least a function of token price and supply. It is monotonic, which means it's always increasing. And it is also predictable or deterministic. So given the same input, you'll have the same output. But as you'll see in later examples, there are lots of variations of this, and this is where it all started. So you could consider this a monotonic bonding curve. So there are a lot of misconceptions about bonding curves, mainly because of the sort of applications that they've been used for. So as you saw, the curation markets as well as automated market makers being developed alongside each other. A lot of people, because of the use of bonding curves for funding or exchanges or various other funding mechanisms, people think they're Ponzi schemes. Uniswap has also been sort of talked about as a bonding curve, and it's kind of a bonding curve. So you'll see some of the sort of properties where it differs later. And I'd just like to give you a little bit of a background on a few simple sort of blockchain or crypto economic concepts that might help understand what I'm going to talk about now. So bonding curves with the introduction of Bitcoin, blockchain with the introduction of Bitcoin introduced the idea of scarcity in the digital domain. So a classic example of this is having an apple. It's unique, it's in the real world. If you take a picture of that apple and you then put it in the digital domain, it is no longer guaranteed that that is unique. It can be copied, shared, spread. And blockchain introduced a mechanism to solve this double spending problem of being able to use a token or something of value more than once. Liquidity, this is a sort of nice way to visualize it in the case of an exchange. You've got willing buyers and willing sellers, and this introduces the idea of liquidity. So liquidity is the availability of liquid assets for transaction and trade. And bonding curves can be used to introduce liquidity for systems. And here is the concept called price discovery, which is, I think, microeconomics, which is the way demand and supply interact with each other and reach an equilibrium point for pricing of some sort of commodity. And bonding curves have been used and can be used as a primitive price discovery mechanism. I think this is probably most prominent in curation markets. Okay, some basic terminology or lingo. Some of these are concepts that are not only for bonding curves, but also token engineering. The idea of collateral and reserve. So collateral is the value that is provided in exchange for a supply of tokens. And the reserve is the pool of value backing the token supply. So in this chart here, you can see a basic curve. This isn't necessarily a bonding curve, but underneath you can see the area of under the curve, which would be a sort of integration by parts, and this green area represents the collateral that is backed by the bonding curve. So the tokens that are supplied along the x-axis would have a collateral backing being the area under the curve. The idea of market cap or market capitalization is something from the sort of financial world. It's nothing new, but in the case of bonding curve, it would be the spot price multiplied by your total token supply. And your supply is the tokens issued in exchange for your reserve collateral. So I'm going to attempt to draw, I think. Zoom will let me. No, it doesn't seem to let me. Okay. A bonding curve function. This is your function that describes a relationship between your token price and your token supply. The spot price is the value of a single token at a point along a curve. So in this diagram here, you can see the current price, and if you were to buy a supply of 10 tokens, you would exchange that for a value in collateral, which would be the highlighted area under the curve. So this is not something I'm going to dive too deep into, but there are a number of formulae and properties of bonding curves that are sort of common properties between a number of different implementations of bonding curves. And one of them is the reserve ratio. And this is the ratio between the reserve or the area under the curve to the market cap, where the market cap is a sort of, yeah, it's the value of your total token supply multiplied by the spot price. And here you can see how varying a parameter such as your reserve ratio can have an effect on the resulting bonding curve. The idea of slippage and price sensitivity, this would be the effect of a token transaction on the spot price. And I think all you need to know here is that the reserve ratio and the inverse leverage ratio, both of these sort of properties affect how sensitive your pricing mechanism is to trading and transactions. And you can, if you were to go and use Uniswap, you would be given a percentage, which would indicate what slippage you would get from transacting. A number of the mechanisms and automated market makers and bonding curves have the idea of an invariant. This is basically, it's a property or relationship that remains constant. If you did basic geometry, triangles have a number of different invariants, and the same holds for bonding curves in a different way. So what is a market maker? It's a mechanism that creates or provides liquidity in exchange for a given token. And coming up, you'll see the concept of automated market makers. So when you're designing a bonding curve, there are a number of different properties that you have, or parameters that you can design around. And they all have different effects. And it's almost a bit of an art, I'd say. So some of the parameters are listed over here. I'm going to go into a bit more detail about each one. Okay, firstly, the idea of time. So bonding curves, a nice analogy for them is a sort of, it's a pool of collateral. And over time, this collateral can change, it can aggregate over time. So there are a few examples coming up in the later presentations about the idea of voting and how people's conviction in a given vote can collect over time, and also token vesting. Pricing, so price differences. Basically on the left, you can see a bonding curve, as we saw earlier, a very basic bonding curve where you've got the same price for buying in as well as selling out. If you were to introduce a different curve for buying in and selling out, you could introduce the idea of taxation. You could disincentivize bad behavior by having this sort of cost for selling out of a market or bonding curve. You can also decide to choose what collateral you want to be held in your bonding curve. So the bonding curve collateral pool, if you were to have Bitcoin in that pool, you would have a very volatile market, and it wouldn't necessarily be truly representative of some idea or thing that you're trying to curate. In the case of a curation market, you would probably want to rather use DAI, which is a stable sort of US dollar tethered or token. And also, one of the questions that came up earlier was fungible and refungible tokens. And this is, once again, some parameter that you would be able to choose. Your supply, basically just whether it's capped or uncapped. So if you have a cap of 10 million tokens, that would introduce different sort of user interaction and behavior than if you had an uncapped supply that's for a market that is intended to be very long-lived. You can choose the function of your bonding curve, and this is your relationship between your price and token supply. You can sort of try and design or drive different actor incentives, and some of the dynamics that you introduce with different functions can only truly be fully understood with modeling, which is a topic I'll briefly cover, and I'm sure some of the block science team will dive into a few deeper discussions around modeling of bonding curves and token systems. Here's a few basic bonding curves: a basic linear curve, quadratic curve, and the common stack curve, which I hope I got right. So you can also, a token engineering system often has sort of a very modular makeup where you could compose different bonding curves with different inputs and outputs. You could have different parameters for different phases of your project or system. And this is sort of a very useful feature of bonding curves, which the common stack augmented bonding curve uses very well in composing a sort of more complex system around voting. So automated market makers and liquidity providers, are they bonding curves? So Uniswap, Bancor, and Balancer all describe some form of mathematical relationship between two or more token pools. They share some properties with bonding curves, and they all have a mathematical pricing relationship with some form of invariant. So Uniswap is described as an automated liquidity provider. They have a relationship described by the function there, where K is the invariant, X and Y are the reserve balance in a token pair. And this relationship gives it certain properties, which we won't get into, but it does share some of the sort of same features of bonding curves. Here you can see a basic model as modeled by Marcus from block science, where it's as your sort of your reserve of one or other of the other tokens, whether it's in this case Ethereum or DAI, as that reserve changes, your price along this curve is adjusted to match this relationship. So Bancor is described as an always available constant liquidity source. It's also got a function that describes some of its properties with an invariant. In the case of Bancor, this invariant is the reserve ratio. So Balancer is a sort of portfolio manager, and it's difficult to see from this image, but it's a 3D image, and It's no longer your sort of basic idea of a monotonically increasing bonding curve, but introduces more sort of dimensions and has some of the same properties. So it extends, it's a generalization of Uniswap's constant product rule and allows two or more tokens, but with arbitrary weights. So if you had a portfolio, or let's say an investment portfolio, and you've got different tokens that you want to keep balanced within that portfolio at different percentages, this would allow you to do that. So what are some of the limitations of when designing bonding curves? So specifically, it comes around because of solidity and the Ethereum virtual machine. Some of the mathematics becomes a bit more complex to implement. You get overflows and underflows, you get front running, you get batch processing of transactions to try and avoid slippage. And here's a picture of some bonding curve code for a basic linear bonding curve. So this is probably the simplest implementation you could get for a linear bonding curve. And basically all you're doing is you're implementing an integral of your bonding function and an inverse integral of that function. And this allows you to calculate both the buying and selling prices for a set number of tokens. So bonding curves, when integrated into token engineering systems, become complex. This is not necessarily a limitation, but it is a limitation if you do not model your system and you do not simulate it properly. And I'm sure you'll hear more about this later. So more and more the engineering practice, basic engineering practice, is being brought to token engineering. And this is introduced sort of more iterative design cycle, where you have your implementation, you can then have a carbon sort of copy model of it. You can simulate the behaviors of your model and try and inform the design and implementation in the real world with different actors, whether it's different users or mechanisms or other systems that you're integrating with. So why would you want to do this? This allows you to validate your designs, test for how robust your system is, find edge cases, check how sensitive your system is to small changes in some of your parameters, and find out what the bounds of your system are. Some edge cases are more obvious than others, and modeling helps to find those that are more complex or less obvious. So how is this done? You can do active modeling and simulation. The CAD framework is open source library that was built by Block Science and allows you to do simulation of complex systems with various things like parameter sweeping, which is changing a parameter and seeing what effect it has on your system, and running Monte Carlo methods, which allow you to run very large experiments on your system. For example, here you see a basic experiment with different parameters and some sort of more Python data science type outputs from it. So what are bonding curves used for in the wild? All sorts of things, which you're going to get a whole range of examples in the later presentations. Some of them are things like system interfaces, voting, community currencies, and funding is also part of this. It's probably one of the ones that have been sort of gotten most of the attention, but there's a lot going on in this space. So what are the trends? Application of engineering methodology, more and more degrees of freedom in your design choices. More variables are being introduced, such as time, and they're being used as a modular part of larger systems rather than simple funding mechanism. Just like to thank contributions from Angelo for the presentation. And there are a bunch of resources, the Token Engineering website being the first one, the CAD discourse channel, and this presentation is on GitHub. with a slightly more extended version if you want to read it. And you can send any questions my way. Thank you.